Dear students, welcome to my fourth class on waves. We have discussed about different types of waves and classification based on the dimension of the medium of propagation of the wave. Waves can be classified into one-dimensional, two-dimensional and three-dimensional depending on the medium through which it is propagating. If a wave is propagating along a line, then such waves are known as one-dimensional waves because it is moving through a one-dimensional medium. If a wave is traveling along a surface which is two-dimensional, such waves are known as two-dimensional waves. And if a wave is traveling along a three-dimensional medium, such waves are known as three-dimensional waves. An example of three-dimensional wave is electromagnetic waves which can travel through three-dimensional medium. Sound waves can also propagate through three-dimensional medium. Now, we have derived as a second order differential equation for representing one-dimensional wave. That is dou square psi by dou x square plus 1 by v square dou square psi by dou t square represent a one-dimensional wave where v is the velocity of the wave and psi is the wave function which is a function of position as well as time coordinate of a wave. Now, this solution of this differential equation is psi of xt is equal to a sin kx minus omega t or a cos kx minus omega t or a e raised to I kx minus omega t. Any of these can be a function of, or any of these can represent the solution of a one-dimensional wave, or a one-dimensional wave can be represented using a wave function psi of xt is equal to a e raised to I kx minus omega t, where x is the position coordinates and t coordinate and t is the time coordinate. Now, if you imagine a three-dimensional wave, what are the position coordinates we can consider for a three-dimensional wave? The three-dimensional wave will be passing through a three-dimensional medium, and the three-dimensional medium will be having three position coordinates x, y and z coordinates, and it also depends on a time coordinate t. And this can be, these three are the position coordinates and t is the time coordinate. So what will happen to this differential equation? Here the differential equation left hand side is having a single term dou square psi by dou x square. For a three-dimensional wave, this will be changed to dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. This will be equal to 1 by v square dou square psi by dou t square. This will represent a three-dimensional wave. This is a second order differential equation representing a three-dimensional wave. So what are the possible solutions of this equation? Can you say a possible solution for this equation? The solution for this one-dimensional wave equation is psi is equal to a sin kx minus omega t or a cos kx minus omega t or a e raised to I kx minus omega t. Similarly, from this we can write the solution for three-dimensional wave as psi of x, y, z, t is equal to a amplitude of the wave e raised to I k dot r minus omega t. This represents a possible solution for this three-dimensional wave. So what is k? K is the wave vector. K is the wave vector. K is the wave vector and r is the position coordinate. R is the position vector. R is the position vector which can be represented as I x plus j y plus k z. This is the position vector. So k dot r represents kxx plus kyy plus kzz, or we can also write this is equal to psi of x, y, z and t is equal to a e raised to I kxx plus kyy plus kzz plus or minus omega t. Instead of kx minus omega t, you have three terms here, kxx plus kyy plus kz is a minus of omega t. This represents a solution for a three-dimensional wave. Thus, a three-dimensional wave is a wave which is propagating through a three-dimensional medium, and it has a differential equation of the form dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square is equal to 1 by v square dou square psi by dou t square. This can also be represented as, that is, this dou square by dou x square plus dou square by dou y square plus dou square by dou z square can be represented as del square, and hence our equation becomes del square psi is equal to 1 by v square dou square psi by dou t square. This also represents a three-dimensional wave. This equation, this can also be considered as a three-dimensional wave equation, which will be having a solution of the form psi of x, y, z is equal to a e raised to I k dot r minus omega t, where vector k is known as a wave vector and its magnitude is known as the propagation constant k, and r is known as the position vector. And omega is the angular frequency and t is the time coordinate. That is it is a differential equation and solution for a three-dimensional wave. Thank you.